Welcome to this video. I'm going to walk you through the specifics of this project and how you want to go about graphing and building your equation. So the example that I am showing you is population growth in Seoul. So, make your presentation look nice. You want to wow me. This is your last summative of the semester. So add some pictures. You guys are probably better at this than even I am. And it doesn't have to be in slides. So my example is in slides, but if you are more comfortable in using a poster or using a Google Doc or using PowerPoint presentation, I don't care the mode that you finish this project in, but make it nice. Add pictures and start with giving me some context of your topic. So why did you pick it and what is the overall trend? So I talked about some unemployment rates of college educated people in Seoul and how that's affecting the population growth. People aren't getting married and having as many children because they're struggling to find a job. I know someone is looking at the number of eggs consumed and looking at one specific year, I think there was like bird flu or something, and there weren't as many eggs, and so eggs were more expensive, and that was a little dip in their growth. So do some research, Google it and learn something and write some context. So that's the first part. The second part is going to be doing a graph. So the easiest way I think to do this is using Google Sheets. So this is just on your Google Drive, make a new Sheets. You also, again, could do this by hand. That's totally fine. I have graph paper in my room, but this is a really easy way. So here's what you do. I took my years, oopsie pie, and I actually made 1975 my year zero. The reason I did this is because if you think about it, if you start at year 1975, then that's your 1975th term in your sequence. And then your 0th term would really be like year zero. So that's like 2,000 years ago. So we don't really care about what was going on that long ago unless you are studying something that was happening that long ago. So I would urge you to make whatever your first year is, make that your year zero, and then go up from there. So this is 1975, this is 1980. So I just think about it as years after 1975. And then you want to insert a chart. So insert chart, and I don't really want a bar graph. That's kind of juvenile. I would say either a line graph or I prefer scatter plots. So here is the chart that I am making. And you can do lots of cool things with this actually. You can customize it. You can change the font, I just kept it the same. Change the font. You can change the axes, change the title, population of Seoul, right? Bold it. I would urge you to play around with this. I know y'all are creative, and I finally want to see it. Make it bold. Circle. How about a star? Who's having fun yet? So go nuts. You also can put the trend line right in there. So I'm not going to approximate my data with a line, but those of you that can work really well. You can actually change it to be linear, exponential, logarithmic, crazy, right? So you can put that right in there. I'm not going to because I don't think mine is all linear. But you can also, look at this, label your data. That's kind of messy, but if you like it, go for it. You can put some grid lines. You get the idea. Go nuts. And then you can copy and paste this right in your presentation. So I'm going to delete that. Link it to spreadsheet. What happened here? It's not what I wanted. As I said, you guys are probably better at all this junk than I am. I want to copy and paste this. Not that. Okay. What is happening? What is happening? Copy chart. There it is. Go away. Here we go. Copy chart, and we're going to paste the chart. There we go. I don't know what was going on there. But see this little update button? That's kind of cool because if you did edit this graph at all, when you press update, it will update it right for you. So that's really cool. All right, so I don't know what that is. Here's my data table. This is also what you should include in your final presentation. I'm going to get rid of this. What is this? Delete this slide. Delete. There we go. Next, I need to find my equations. So this is probably the trickiest part of this project. So I'm going to walk you through how to find both an arithmetic and a geometric equation. Listen up, folks. You do not have to do both. You don't have to do both. I'm doing both so that no matter what kind of data you have, you know how to do it. But don't feel like you have to do both. So here's the data I'm going to use for my arithmetic equation. It's the first couple data points from my graph because you can tell that this is really nicely linear. My first 4 data points are like perfectly linear. So for these data points, I'm going to do arithmetic, and then for these data points, I'm going to do geometric because this looks like exponential decay to me. So let me swing over here and show you how to do this. So looking at my data, I know that my year 0 is this number right here. So I already know my term 0. Now I just have to find my common difference. We know how to do this though. To find an average common difference, I'm going to do this minus this divided by this minus this. So my denominator would be 15 minus 0. My numerator is going to be these two very large numbers subtracted from each other. Oh no, I'm going to run out of room. Okay, so plugging that into my calculator, I get a common difference. Let's see here. Divided by 15. I get an average difference, common difference, of 247,336.4. Now, you might be saying to yourself, it's not going up by that every time. No, you're absolutely right. It's not going up by that every time, but this is our approximation. This is it's going up by about that every time. So our model is not going to be perfect. It's just an approximation. So my equation is my common difference times n plus my 0 term. So I'm going to add this big number, and this is my arithmetic equation. So that is how you would go about finding your arithmetic equation. Next, I'm going to show you how to do a geometric. So here's my data. This is my last couple data points. And I'm going to find my geometric equation. I'll probably use the 0th term. So I'm going to use that equation. I know my 0th term. Remember I said just make your first term 0. So this would be 0, 5, 10, 15, 20, 25, 29. Yeah. So just make whatever your first term is, your 0 term. So then to find about my ratio, I do this number divided by this number. So those are going to be kind of a big number, but you're going to take your last number. and we're going to divide it by our first number because I want to represent all my data. So we're going to take whatever that is, and then we are going to root it. So once you divide the last term with the first or the 0th term, I get a ratio of about 0.947. But now we have to root that. So let's see, from 0 to 29, I'm going to take a 29th root, which is kind of weird, but this is why we have calculators. So I'm going to find my 29th root and 0.947, and I get a multiplier of 0.998. So it's definitely exponential decrease, but it's not a lot of decrease, right? So my equation would look like a sub n equals my 0th term, which is this big number, times my ratio to the x. And that would be my geometric equation. So whatever your last term is divided by the first term you have, and then you root with however many spaces are between them. And that would be your equation. So let's look back. Oh, don't look at my emails. And there you have it, my arithmetic equation and my geometric equation. And the next step you have to do in the project is to make a prediction. So I picked the year 2020. You don't have to pick that year. You can pick whatever year you want to predict. And whatever you just have to plug that into your equation. So because I started my equation from 1975, 2020 is 45 years after 1975. So that's why I plugged in 45 here, right? 2020 minus 1975 would give me 45, if I can do math correctly. So that's what I would plug in, and that's going to give you a prediction for your scenario. So I did the same thing for geometric. After you complete that, then I want to see you write a little reflection. So why do you think your prediction was good? Why do you think it was bad? Maybe your data is pretty nicely modeled with a linear or a geometric pattern. Maybe it's not, and that's why your prediction isn't that accurate. Maybe you think your prediction is right on. Actually, my prediction with my geometric is pretty good. Like, it actually looks like that could be my population next year. It's pretty closely modeling the data. Just write about what you learned. Like, I'll bring back that egg example. Someone researched why there was a dip in their data in that particular year when there was an egg shortage. So do a little research. Figure out, why is it growing? Why is it decreasing? Why did it have a jump up this year, a jump down this year? Like, this is your chance to use math to study something you're interested in. And then last but not least, include your sources. I don't really care about APA, MLA. Don't tell your English teacher that. But I do want to see sources because I do want to check to make sure you're not making this up. Or, I want to make sure that you're finding good sources and you're finding good data. So you can see this little article, which is about unemployment in Korea, if my computer ever loads. There it is, the Korea Herald. So there you have it. This is your final project. Wow me, this is the last thing you're going to do. So have fun with it. Pick something you're interested in and ask for help if you need it. All right, good luck.